Today I will explain generic class parameters. Here you have waiting a class called storage, and this takes a parameter of t. This t can be of any data type. So it can be an int, a string, it could be another object. And what this does, it has a private variable called t, and that private variable is set using the item supplied in the argument using set item. But when you use this class, this t will become the data type that you want. If we scroll down here, we are now defining a storage class we declared up here. We're creating an instance of it using new and passing it an argument of int. This int will then go and replace the t here and the t here. So you can imagine this will now become private int underscore item, which is a private variable. When you pass in an argument to this function, it expects an int, so you can't pass it a string anymore. So this will provide type security. We're now creating a storage instance which is of type string. So now this class will allow for strings to be input here, and you can see we're setting that. If I run this, you can see here we've got our variable printed, which is the integer 42, and hello generic, which is the text we set here, and this 42 that we had there. Here you can see the two values that were printed. You can use generic class to simplify your code. So an integer class and a string class. Both of these classes have the same private properties and in public methods. So as you can see, they both have the same. Then initiate these classes by calling int storage and creating a new and string storage. So rather than having to write two classes, you just write one generic class. This is how you do it. So you declare the storage class, and this time the type parameter is by this t, and that t is then referred to for each type. For example, we had int here, but actually now it's type t, which the user can determine and decide what type they want. Then you can initiate this class by using storage int or storage string and create a new instance of it. And then you can store whatever item that you want. So in this instance, you could store a string, or in this instance, you could store an integer. So this would make your code reusable. You are only writing one class. It's easier to maintain as well, rather than having to maintain two separate classes. But just imagine if there was another method added here, you'd have to add it to two classes, while in this one, you only have to add it to one class. Definitely, I would use generic version of this class to make it easier to maintain your code and make your code reusable and easier to understand. It's important to understand value types in C#. Value types actually hold the data directly rather than memory address reference. Things like int, long, byte, as you can see here, are all value types, including float, double, character. So this is just a single character, Boolean, decimal. Notice decimal can be used for monetary calculations. You will notice that there is no mention of a string in the value types. Although there is a character, the car actually holds the value and the data directly. So here A is held directly as part of this variable. So this isn't an address in memory where the data is held. So it is important to understand the distinction between a string and a car. Value types are also known as native data types in C#, and you should be aware of them. If I run this, you can see the different value types printed, and there you are. These are all value types. Reference types are important to understand in C#. You have string reference type, array reference type, class reference type. These variables do not hold the values directly. They hold address in memory or in the heap where this value is stored, and the same would apply to an array. Same would apply to a class. Here, variables would actually store the reference memory address where this object is stored on the heap. Remember, native or primitive types in C# are stored in the stack, while objects are stored on the heap, and the address of that object on the heap is stored in the variable. Here's a picture that demonstrates this. So you have two variables, s1, s2, strings, and when you say s2 is equal to s1, it points to the same memory address location as s1. So both of them are accessing the same object in memory, unlike primitive data types, which actually access object and make a copy of it on the stack. So just make sure you understand this important distinction between reference types, such as string, arrays, class, versus native data types and primitives, such as int, boolean, float, double. I'm declaring a variable for string s1 and s2, and I'm saying s2 is equal to s1, and I'm printing out the result. What do you think the result of that will be? It will be ABC. And you're right. But this is because string s1 and s2, when s2 is assigned s1, they refer to the same object. What do you think will happen here when I say s1 is now equal to def? What would the output be of s2? String is a reference type. If I run this, and you can see it has printed ABC for the first one and the second one. So both of them have the same value. Why has that happened? Because this diagram says they are reference type, and when you say s2 is equal to s1, they refer to the same object. But remember, strings are immutable. They cannot be changed. So a new string here, when you say s1 is now equal to def, a new string is assigned, and the reference of s2 is still referring to the first one, so the reference is never updated, or the second string. So just remember, strings in C# are immutable. They cannot be mutated. It always creates a new version of it, and the references do not automatically transfer between variables, as shown in this example. So whenever you create a string, it creates it on the heap and gives it a memory address. When you then go and update that, a new memory address is created and a string is stored there. Previous references are not updated. The string variable cannot be shared across multiple variables accessing the same location if you want to change them. An alternative would be string builder. String builder allows you to create the object and assign it to two variables, and then you are able to clear the value in any of the variables or change the contents of the variable, and it would be reflected accordingly in second variable. So they both are linked to the same address in memory. Then string builder is mutable, so it can be mutated, or you can share the string builder across two variables and keep them in sync. But remember, string type is not shareable across two variables because it is immutable. So make sure you use string builder if you want to share values and update them across two different variables. So if I run this, and as you can see, what will happen? You can see here that we printed ABC first because that was set, and then we printed def. So this is all using the second variable. So you can see they do refer to the same object in memory and the same address, and it has updated accordingly. So I have an interesting unmanaged code situation here. As you can see, I've got a pointer, and this pointer actually points to the address of this variable number. So the question is, this is in scope 1. And in scope 2, I can't really access this variable. And just to prove that, let me just take that off. And as you can see, the compiler complains and says syntax checking not valid due to CS0103. So if I comment this line out, can this pointer still view this value? Let's run this and find out. And as you can see, yes, the value here is still accessible by the pointer here in scope 2. Now, just because you can doesn't mean you should. So don't use pointers and unmanaged code in your C# projects unless you know what you're doing. In C#, you also have the pointer types. These pointer types are essentially pointing to an address in memory, and that address could be of another variable or an object. So in this instance, we're declaring pointer, which is of type int. We are indicating it's a pointer by using this asterisk. This pointer is then pointing towards this variable here, which stores the value 10. We can then access this pointer and the value it holds and the address of it by converting it to a long and pointer, or we can access directly the value that the pointer is pointing towards, in this instance, the number 10, by appending an asterisk to it. We can also modify the value by again using the same technique as reading the value by then using asterisk pointer and then the value it should hold. This will modify the value of this variable. Then we can see that we can change variable directly as well, and it will still work. The address of the pointer will stay the same during this process because that's stored on the stack. So if I run this, and as you can see, the address stays same, but the values change. Even the one that we change with the pointer, the new value is printed. And as you can see, the final value is 30. So yes, pointers can be used to modify and access underlying values directly that the pointer is pointing towards without having to use the original variable name. If you are using unsafe code in C#, such as pointers, you will get this error message when trying to build your project. So you need to add a setting to your CS_proj file, add a setting called allow unsafe blocks, and set that to true. And then you will be able to compile your programs. So if I were to run this, and as you can see, my program works by simply adding in allow unsafe blocks. This will allow for unmanaged code to run in your C# programs. You can change the startup object in Visual Studio Code for any project. So let's say I've got two program files here, two CS files, and I've got two objects, one class called pointer type, and then under the class called program. If I want to run, rather than the program one, I want to run pointer types, what you can do is change the CS_proj file and add in a property called startup object. And then within here, you just type in the name of your other file for the class. So in this case, it's this. So I will just copy that and then I just paste that here. And then if I save this and run, then your pointer type class will now run rather than the program one. So this lets you change the startup object in Visual Studio Code for your C# project. Remember this line, startup object, and type in the class name that you want to run. In C#, this is how you declare a pointer. So you type the word int, for example, at the data type, because this pointer would point towards an integer, and then you key in an asterisk, and then this will be treated as a pointer. To declare multiple pointers, you can use int and asterisk, and then separated by a comma, declare your two variable names. So these would then become pointers. This is different behavior to C and C++. This is because in C and C++, the pointers should be declared like this, where the asterisk goes before the variable name. But in C#, the asterisk always goes next to the data type. So both of these would be of pointer types pointing to an integer. Now, in C and C++, what would happen is this syntax would actually result you in a pointer here for P2, and P3 would actually just be a normal integer. So C++ and C syntax cannot be used in C# because here you have have int and asterisk and p4 and p5, which in C and C++ would be both pointers, but in C# this is invalid syntax. So hence the reason for p3 here, you can't assign an integer because p3 actually is a pointer that points to an integer. So I've just commented these two lines out and added p3 just to demonstrate this. If I run this, and as you can see, all of them point to this value 42, which was assigned right here, and address for all these is the same. This points out that p1, p2, and p3 are all pointers, and the declaration is done in this way using int, asterisk, and then the variable name separated by comma. Can a pointer point to another pointer in C#? So here I have a pointer p1 and another pointer p2. First pointer p1 is pointing towards the address of this number variable here. So can p2 point to p1 and get the address of the number variable here? And to demonstrate this, let's run the code and find out. And as you can see, both of them, p1 and p2, are printed and the addresses are the same. And also the values are the same, though both of them do point to the same address and the same value. So this demonstrates that you can actually point a pointer to another pointer that will loop back to the original variable and the storage location on the stack.